For example 1, we are going to determine whether our equation has symmetry with respect to the x-axis, the y-axis, or the origin. And the way that we test algebraically if our equation has symmetry with respect to the x-axis without even looking at the graph is to take all of the y's in the equation and replace them with a negative y. And before I go ahead and do that, I'm going to actually write down my original equation. I always do that for every test. So if I wanted to, I could even do a little assembly line here. I typically don't, but I want you to see that I do this for each and every single test. And it is not necessary, you don't have to do it, it's just something that I like to do. But I start with writing down my original equation, and then I'm going to go ahead and start replacing my y with negative y. And I only have one to replace in this equation, it's not that interesting, so there it is, I already did my replacement. And then I'm going to bring down the rest of my equation, and I'm going to clean it up. Doesn't look like I have very much to do to clean it up except for to remove parentheses. I recommend that when you're substituting in, whether you think you need it or not, that you always use parentheses as you sub in. And there we have it. I have negative y equals x squared plus 2 once I substitute in a negative y for y. Now I'm going to look at my cleaned up equation and compare it to the original one up top here. And I want to know, or I want to look at if they are the same. So my new equation and my original equation, I'm comparing them to see if they're the same, and they're not. But I do notice that that first term right away is not matching based on the sign. So I'm going to try to make them match by pulling a little trick out of my sleeve. I'm going to multiply my entire equation by a negative 1, or you could also divide your entire equation by a negative 1, which is going to flip all the signs of each term, and then maybe that little trick will help my new equation look like the original. And then as I go ahead and clean the rest of it up, I see that it didn't work. So that kind of failed on me right here. But you never know. So if you cannot mental math that through, then go ahead and try it. And that little last trick by dividing everything by a negative did make the first y term match, but it made everything else not match. So the answer to this first part of example 1 is no, that I do not have x-axis symmetry. If my new equation looks like the original, then that answer would be a yes. I would have that kind of symmetry. Now we're going to go ahead and test for y-axis symmetry. And I start by writing my original equation down. That's how I like to do it. You can skip that step if you want to. However, you can't skip the next step, which is to take all of your x's and replace them with a negative x. So if you're checking for y or you're testing for y-axis symmetry, then you're going to take all of your x's and replace them with a negative x. So I'm going to go ahead and substitute in, and don't forget I said a little bit ago that you need to use parentheses when you're subbing in. Don't skip that part. Make sure you're using parentheses whether you think you need them or not. And then I get y is equal to positive x squared plus 2. And a negative x squared expanded out is negative x times negative x. And a negative times a negative is a positive, and x times x is x squared. So you end up with positive x squared. And then that's all the cleaning up that I can do. So I'm going to compare my new equation with the original. Notice I did not divide everything through by a negative 1 because my first term already matched signs, so I didn't try to do that little trick. And then I see that the answer is yes this time. My new equation looks like the original, and therefore, since they are exactly the same, I do have y-axis symmetry. And then finally we have symmetry with respect to the origin, and I'm going to test for that by replacing both my y with a negative y and also my x with a negative x. I have to replace both. So let's go ahead and do that. I'm going to take my y and replace it with a negative y, and then my x gets replaced with a negative x. And then I need to clean it up. Remove parentheses, you get negative y, square negative x, you get positive x squared. Bring down our 2. And I notice that my first term does not match sign with my new equation down below. So I can try to pull that little trick out of my sleeve by flipping all the signs across my equation by dividing by negative 1. I get y equals negative x squared minus 2, and my trick didn't work. It did make the first term match, but it did not make the rest of the equation match. So comparing this to the original, they are not the same. So the answer to that is no. Let's go ahead and determine whether this equation has symmetry with respect to the x-axis, y-axis, and origin. Okay, so when we test for x-axis symmetry, we are going to replace our y with negative y. I always like to start with writing my original equation down. You don't have to do this, though I do recommend it. And I'm going to go ahead and substitute in a negative y for y, and then I'll clean it up. I get x squared plus y squared is equal to 5. Just note that negative y squared is equal to a negative y, or expanded out to a negative y times a negative y. And a negative times a negative is a positive, and y times y is y squared. So that's how that cleans up. And then I look at my cleaned up equation and I compare it back to the original equation, and they look exactly the same. So this equation has x-axis symmetry. Let's go ahead and do y-axis symmetry. When we test for y-axis symmetry, we replace our x with a negative x. So again, I take the time to write this down. It actually just helps me make sure that I am subbing in everything correctly, and it's easy to just compare my new equation by looking right above at the top level. So I just like to do this. If you want to skip that step, you can. So we have negative x squared plus, y squared is equal to 5. And then when I clean up negative x squared, it's going to turn into a positive x squared. And when I compare my new equation with the original, I see that they look exactly the same. So my equation also has y-axis symmetry too. And let's go ahead and test for the origin. You're replacing both your x and your y with a negative x and a negative y. So I get negative x, I like to write the original down. X squared plus y squared is equal to 5. And we get negative x squared plus negative y squared is equal to 5. And then this term is going to clean up to positive x squared. The second term is going to clean up to positive y squared. Bring down our equal 5, and we're ready to compare. You don't have to pull that trick out of your sleeve where you're multiplying or dividing by a negative throughout your equation, because if your first term already matches in sign, then there's no reason to flip anything else. So all three of these tests, I did not have to flip the sign, so I didn't do it. So when I compare my equation with the original, my new equation with the original, the answer is also yes again. So this equation gives you all kind of symmetry, x-axis, y-axis, and origin. Let's go ahead and once again test for x-axis, y-axis, and origin symmetry. So I'm going to start by writing down my original equation, which is not necessary, but I recommend. I'm actually just going to go straight across this time and make a little assembly line. And one more time. I just don't really like to be over here at the end of the problem testing for origin and then having to look way back over to the left side of my problem. I just feel it's easier just to look above to either substitute into or even compare your final cleanup with the original equation. All right, so for x-axis symmetry, we are replacing our y with negative y. So you get negative y equals 5x to the 6 minus 3x squared minus 7. The only thing you can do is remove parentheses. And I noticed that when I try to compare my new equation by the original equation, the y terms in the front don't match signs, so I'm going to pull a trick out of my sleeve and I'm going to try to make those first terms match by dividing through by -1, and that will make the sign match. I'm going to clean up the rest of the terms in my equation and see what I get. And it worked really well for making my first term match in my equation, but it kind of ruined the rest of the equation. Nothing else really matches. So that is a no, it does not have x-axis symmetry. Let's go ahead and test for y-axis symmetry. We replace our x's with negative x. So I get y equals 5 times negative x to the 6 minus 3 times negative x squared minus 7. And I just want to up here at the top show you what negative x to the 6 looks like all expanded out. It's negative x times negative x times another 2 negative x's and times 2 more. So I have 6 of them being multiplied all together. And you can see that for every 2 negative x's that I multiply, I actually get a positive result. So these 2 negative x will turn positive, these 2 negative x's will result in a positive, and these 2 negative x's will result in a positive answer. So I end up with a positive times a positive times a positive. My final overall term is going to be positive, and then I just have 6 regular x's all multiplied together, which gives you back x to the 6. So this whole entire negative x to the 6 is going to be positive. And then I just multiply it by the 5 in front, and that's what you get. Now, this next negative x squared looks like just maybe the first 2 x's above here that are being multiplied together. Negative x times negative x is going to give you positive x squared. So this is going to calculate back out to be positive x squared. However, I am multiplying it by a -3, so my overall term is going to be negative 3x squared. And then I'm going to bring down that -7, and let's go ahead and compare. I don't have anything else to clean up. All my parentheses are gone. My first term's already matched, so there's no need to divide by a negative. And let's see. I think everything matches, so this is a yes. And let's finally do symmetry with respect to the origin, where you replace both the x and the y. And then I'm going to get negative y is equal to 5 times negative x to the 6 minus 3 times negative x squared minus 7. And then removing parentheses, I just get a negative y in front. Next term was positive, next term was negative, and then -7 on the end. And the first term doesn't match in their signs. I have a positive y up top and a negative y down here at the bottom, so I can try to pull that trick out of my sleeve and then see what happens. And I already know it's going to fail. I can kind of think ahead and see that this isn't going to work. But you never know, especially when you get to your homework. You guys can't always tell that easily that it's going to fail. So if your first term doesn't match, go ahead and try to divide everything by a negative. So this was a no, and that is it.